over the course of years, transportation became an essential part of our society. People moving from a place to another, transporting goods from the facility to the market, and in-house deliveries are utilized almost everywhere. All of these are made possible by the existence of one important structure we all know as the road. Highways and roads, as we all know, is not as simple as a straight pavement. It is designed based off the environment it is erected to ensure not only the travel efficiency, but so is the safety of the people who will use it. And in order to do so, different highway design components is implemented, such as the horizontal curve. It is one of the most important transition elements used by transportation engineers in designing a road. It allows the vehicle to gradually change course in an intersection to ensure the safety of the driver and the vehicle traveling on the opposite lane, preventing a possible collision or a vehicular accident just like this one. There are two forces acting on the vehicle when it is subjected to a turn. The gravity prevents the vehicle from flipping over by keeping it grounded. Centrifugal force, on the other hand, is the force that makes the change of course possible for the vehicle. It is an external force created by friction generated from the interaction of the wheel and the pavement of the road. So basically, it is a force directed towards the center of the curve, allowing the moving object to follow the curved path. There are different types of horizontal curve. First is a simple curve, which is basically a simple arc between two straight lines utilized to impose a curve. So this design is seen imposed in the North Luzon Expressway along Mabalacat, Pampanga, as seen in the picture. Next is the compound curve, a type of horizontal curve composed of two simple curves with different centers that trails the same direction, creating a semicircle. This design is seen imposed in Kinan Road along Baguio Benguet. Lastly, we have the reverse curve, which is another set of combined curves placed on opposite orientation, creating an S-like figure. This design is implemented along Kinan Road, Baguio Benguet.
Vertical curves are used in highway and street vertical alignment to provide a gradual change between two adjacent grade lines, typically at an intersection, to ensure a safe and comfortable ride for vehicles. Some highway and municipal agencies introduce vertical curves at every change in grade line slope, while others introduce it only when the net change in slope direction exceeds a specific value. There are two types of vertical curve. The crest curve, where the alignment of road changes from downhill to uphill, and the side curve, where the alignment of road changes from uphill to downhill. It usually happens when two opposite gradient meets. However, there are more conditions why they are formed, like when a gradient meets another mild gradient, when a gradient meets a level 0 gradient, and when a gradient meets another steeper gradient. Ang clip na mapapanood nyo sa susunod ay from Touring Japan, wherein ipinapakita yung Eshima Grand Bridge na malabiyaheng papuntang langit. Kailangan natin i-avoid yung ganitong design na tinatawag na roller coaster or the hidden up type of profile. In order to do that, all types of sight distances must be taken into account in the design, na i-discuss later ni Mr. Binasahan. This clip is from Katsunwagen TV, where he is driving from Imus to Alabang by the Daang-Hari Road. Daang-Hari is a multi-lane toll-free road that connects Muntinlupa and Las Piñas to the cities of Bacoor and Imus in Cavite. It consists of multiple vertical curves as well as horizontal curves. So kapag magde-design tayo ng vertical curves, lagi natin isaisip ang comfort at safety ng mga motorista.
Have you ever experienced being involved in a car accident? Is it because of the poor visibility or the lack of braking distance? In this part, we will understand how sight distance works and how to avoid such accidents. Sight distances. The safe and efficient operation of vehicles on the road depends very much on the visibility of the road ahead of the driver. One of the important aspects when designing a curve comes from the simple but crucial fact that drivers need to see what's coming up to be able to react accordingly. Sight distance is the length of the roadway required to recognize and respond to changes. It varies by driver reaction time and vehicle speed. The slower you react and the faster you're going, the more distance you need to observe turns or obstacles and decide how to manage. Sight distance also varies by what is required of the driver. The amount of roadway necessary to bring the vehicle to a stop is different than the amount needed to safely pass another vehicle or avoid a hazard in the lane. Even if a curve is gentle enough for a car to traverse, it may not have enough sight distance for safety due to an obstacle like a wooded area. In this case, sight distance will require the engineer to make the curve even gentler.
Speed is considered one of the major aspects in designing a roadway. For instance, a fast-moving vehicle that travels in a circular path or a curved path is subjected to an outward force known as centrifugal force, which makes a vehicle experience overturning and skidding. To overcome this force and for safe travel of a vehicle, the outer edge of the road is raised above the inner edge. This is known as super elevation or banking of a road. In curved sections, engineers make the outside edge higher or super elevated above the center line to help with friction. Any object going around the curve needs a centripetal force toward the center of the turn. Otherwise, it will just continue in a straight line. For a vehicle, the centripetal force comes from the friction between the tires and the road. Rubber tires provide this friction against a road surface, but it's not completely reliable. It can be reduced by precipitation. Different weights of vehicles and condition of tires also create variability. Super elevating a roadway around a curve reduces the need for tire friction by utilizing the normal force from the pavement. There are two ways to solve for the super elevation of a road. Here in Dasmariñas City, Cavite, along the stretch of Governor's Drive, there's a curved path that is super elevated near the Piala Bridge. Vehicles along this roadway can go as fast as 60 km per hour. So as to keep them safe, the outer edge of the road is raised above the center line. This roadway feature provides motorists with a great driving experience and also aims to protect drivers and pedestrians. Therefore, we must always follow speed limits. Have a safe travel.
Did you know that spiral curves are originally designed for railroad? Today, spiral curve is widely used in roads of all types. Apparently, spiral curves smoothen the transition from horizontal alignment into simple circular curve. It provides a natural path to follow and lets a vehicle travel with ease. Naibibigay ng spiral curve ang natural path na yon dahil sa paunti-unting pagbabago ng sukat ng radius. At dahil paunti-unting nagbabago ang radius, it undergoes gradual change of required super elevation. At yung pinagsamang spiral curve at super elevation ay nakakatulong upang ma-counterattack ang centrifugal force. This centrifugal force is induced on vehicles when traveling on curves, na dahilan kung bakit nagkakaroon ng sudden jerk sa mga passengers. Additionally, there is a relaxing effect because abrupt connections are absent. Dahil nga nagpo-provide ang spiral curve ng natural path, nagre-resulta ito ng natural rhythm, allowing the driver and other passengers to enjoy the landscape outside the vehicle. The clip you are seeing on North Springs at this moment is from PFH TV, a clip from a driving tour from Manila to Baguio. This road is the Marcos Highway that is composed of multiple spiral curves and super elevations, and therefore, you are invited to this virtual car ride for the remaining seconds.